Okay, next example, we want to integrate over some region E the function x squared plus y squared. And then E is going to be the region inside x squared plus y squared plus z squared equals 4 with y greater than or equal to 0. Okay, so again, maybe not necessary to draw a picture, but it's good to. Okay, so we're going x, y, z. We have a sphere of radius 2, and then y greater than 0 is over there. So actually we're doing the far half of the sphere. It's a little bit hard to shade, but everything on the other side of the xz plane from where we are. Okay, going that way. And in the negative direction as well. Okay, that's not a great picture, but maybe you get the idea. Hopefully you do. So let's see. Let's remember the conversions. X was rho sine phi cosine theta, and y was rho sine phi sine theta. So then x squared plus y squared, we'll be able to factor out a cosine squared plus sine squared. So x squared plus y squared is rho squared sine squared phi. Okay, so that's the conversion. We need 3 integrals, rho squared sine squared phi. And maybe I'll just erase this picture since it wasn't very illustrative. Then I need still a rho squared sine phi as part of my d rho, d phi, d theta. Okay, so a lot of terms going on there. And then in that half circle, what's happening? So rho is certainly going from 0 to 2. We're bounded by a circle of radius 2. Phi is going all the way, because you need to go all the way down to the negative z-axis, so 0 to pi. Phi has a maximum value of pi before we start repeating things. And then theta, we're taking the, if we're just in the xy plane, we're taking just the top half. So theta is going from 0 to pi as well. Okay, let's see what happens here. So let's collect everything. 0 to pi, 0 to pi, 0 to 2. This is rho to the 4th sine cubed phi d rho d phi d theta. And then rho to the 4th integrates to rho to the 5th over 5. Sine cubed phi, we're going rho goes from 0 to 2, d phi, d theta, and so we put that in, we get 32 over 5. 32 over 5. And then we have to integrate sine cubed phi, d theta. So remember, we have an odd power of a sine, which means we can write that as sine phi times sine squared phi, which is 1 minus cosine squared phi. So to integrate an odd power of a sine or cosine, take one of them out, and then that'll be part of your u substitution. So u equals cosine phi, and then du will be negative sine phi d phi. Or other way around, sine phi d phi is what we're going to replace with negative du. Okay, then this is 0 to pi. This is phi going from 0 to pi. We have 32 over 5. We have a negative sign. We have a 1 minus u squared. So actually with that negative sign, maybe we'll distribute that in, and we'll get a u squared minus 1. That'll be easier. We have du d theta. Always reduce the number of negative signs if you can. Negative signs make things hard. Okay, now we can integrate. So 32 over 15, I guess, u cubed, minus 32 over 5 u, as phi goes from 0 to pi. Maybe in this case, instead of writing another line, I'll just convert the bounds. This is another option. Maybe some of you always do it this way. So when phi is 0, cosine phi is 1. When phi is pi, cosine phi is negative 1. And it's okay to have the bounds upside down. You just plug them in. Don't even think about it. 0 to pi, upside down meaning the top bound is smaller than the bottom bound. That's fine. That's a perfectly defined integral. Negative 32 over 15 plus 32 over 5 minus 32 over 15 minus a negative is plus 32 over 5 again. Okay, d theta. So that's just going to integrate to ugly fraction times theta. Plugging in the bounds theta will get us an extra factor of pi, so we just have to figure out what this fraction is. Let's see, this is 32 over 15 minus, let's do one of these, plus 3 times 32 over 15 is 32 over 5. So we end up, that's 2 times 32 over 15. So one of those is 64 over 15. That's that, like the first part would be 64 over 15. Here's another 64 over 15. So we get 128 over 15. Let's just write out the integral. But what will happen is we just get a factor of pi from integrating theta. Pi. Great. Okay. So purpose of this problem was to remind you about integrals, which I don't know if we're 100% fresh on yet, but odd power of a sine and cosine is one type of integral that you should know how to do. And then also I want to show you what happens if you try to do it in cylindrical coordinates. So let's go back, because maybe these conversions are too annoying. Maybe you don't like that about spherical coordinates. Maybe you don't like this. Those are things that I mildly dislike as well. Okay, so let's try to do it in cylindrical then. If we don't like those, maybe we can avoid it. Okay, so what happens in cylindrical? This looks perfectly fine for cylindrical coordinates. We're going to integrate. We have r, theta, and z, right? And then x squared plus y squared is going to be r squared, so that'll be nicer. So we'll have r squared. We'll have r, dz, dr, d theta. Okay, and then let's see, we're in the half. So in the xy plane, we're in that top half of that circle of radius 2. Did I go up to 2? I did. Okay. So let's see, r is going to go from 0 to 2. Theta is going to go from 0 to pi. And then z, now we have to go into 3 dimensions. We have to promote that to a sphere. We want the whole half of that sphere. So z is going to go, but each vertical line goes from the bottom half to the top half. So negative root r squared minus x squared minus y squared to positive root of that, or negative, this is the root of r squared minus little r squared, right? If we're in polar. R squared minus little r squared to positive r squared minus little r squared. Okay, so is this easier or harder than the spherical one? I don't know. There was a lot going on in the spherical one too. We had to do some conversions. So let's just do one or two more steps of this. This is an r cubed, but when we integrate with respect to z, that's just a constant. So integral from 0 to pi, integral from 0 to 2. I have r cubed, z, I have to put in z goes from negative r squared minus little r squared to positive r squared minus little r squared dr d theta. And so then when I put that in, I get double that root, because subtracting a negative will be positive. So 2r cubed root big R squared minus little r squared dr d theta. And now integrating with respect to theta is easy, but all it's going to do is bring in a factor of pi. So even if I did it first, it doesn't make it easier to integrate with respect to r. Integrating with respect to r is going to be really hard. This is actually, if it were just an r out here, I'd be good, but I have an r cubed out there. So this is hard, and this is probably another thing that would result in trig sub. So just like going from rectangular to polar, we can avoid a trig sub. Going from, sometimes if cylindrical is still too hard, going from cylindrical to spherical, we can avoid a trig sub as well. So wanted to show you this example so that you could see that there is a use to spherical coordinates. We're not just making you learn random things that I said weren't even helpful for finding volumes.